Welcome students. In the previous lecture, we have studied some information about carboxylic acids. Here we are proceeding further. The next variety is a dicarboxylic acid. The name indicates it contains two carboxylic acid groups, and these groups are present one at each end of the saturated hydrocarbon chain. Its general formula is these two carboxylic groups at the end, and in between these the CH2 group with n number, where n equal to 0 or 1 or 2 or 3. Nomenclature: most simple dicarboxylic acids have their common name, and in IUPAC system they are named as alkane dioic acids. Okay, what is done in IUPAC system? Add the suffix dioic acid to the name of the parent alkane containing both carboxylic groups. The common name of the first acid is oxalic acid, but in IUPAC there are two carbon atoms, therefore it is ethane dioic acid. Common name of the second acid is malonic acid, but in IUPAC 3 carbons, therefore it is a propane dioic acid. Succinic acid is the common name containing 4 carbon atom acid, where IUPAC name is butane dioic acid. The common name is adipic acid, where the IUPAC name is hexane dioic acid. Students, we are going to study succinic acid. This is butane dioic acid. The methods of formation: first, from ethylene dibromide, it is treated with sodium cyanide. This is ethylene dibromide treated with sodium cyanide, forming dicyanide compound, which on hydrolysis gives succinic acid. The second method of formation is from maleic acid. On reduction, this bond is reduced, and therefore succinic acid is formed. This reduction in presence of nickel. Chemical reaction: action of heat. On heating, succinic acid loses a molecule of water to form anhydride, that is succinic anhydride. The temperature is 300 degrees centigrade. This is succinic acid. This OH and H, this water molecule is lost, and anhydride, that is a cyclic compound, is formed. Action with sodium bicarbonate. Okay, action with sodium bicarbonate, it gives first monosodium salt. The hydrogen is replaced by sodium, and further the second hydrogen is also substituted by sodium, giving disodium salt. Then action with ethanol in presence of acid. Of course, acid on treatment with alcohol gives ester, and therefore with ethanol succinic acid gives diethyl succinate, that is a diester of succinic acid. Hydrogen is replaced by this ethoxy group. Okay. Uses: it is a very important laboratory reagent. It is also used in the manufacture of high polymer esters, and it is used in the manufacture of lacquers and dyes. Now, next dicarboxylic acid is phthalic acid. Methods of formation: first method is from orthoxylene. Orthoxylene on oxidation with potassium permanganate or vanadium pentoxide gives phthalic acid. This is with potassium permanganate gives phthalic acid, or with V2O5 gives phthalic acid. Oxidation takes place. Second method from naphthalene. Naphthalene on oxidation at 573 to 773 Kelvin gives first phthalic anhydride, which on treatment with alkali gives disodium salt, which on hydrolysis gives phthalic acid. This is a naphthalene. On oxidation gives phthalic anhydride. On treatment with alkali gives disodium salt, and decomposition of this disodium salt in presence of acid gives phthalic acid. Chemical reactions of phthalic acid: action of heat. Phthalic acid on heating loses a molecule of water, giving phthalic anhydride. This is a phthalic acid. On heating forms anhydride, that is water molecule is lost. With soda lime, phthalic acid on treatment with soda lime first gives benzoic acid by decarboxylation of one carboxylic group, and further treatment gives benzene with decarboxylation, that is removal of another CO2, and thus benzene is formed. With ammonia it gives phthalimide. Okay, with ammonia it gives phthalimide. Uses: first, it is in the manufacture of dyes and also used in the preparation of benzoic acid and substituted aromatic acids. Then carboxylic acid derivatives. The compound which is derived from acid is called as carboxylic acid derivatives. For example, acetyl chloride, which is obtained from acetic acid. Acetyl chloride, IUPAC name is acid chloride. Acetic anhydride, IUPAC name is acid anhydride. Ethyl acetate, IUPAC name is acid ester, and acid amide, its IUPAC name is acid amide. Okay, from this we are going to study the first two varieties. The first variety is acid chloride. Okay, it is a volatile pungent smelling liquid, as this compound cannot form hydrogen bond, and therefore it has low boiling point and insoluble in water. It fumes in moist air due to hydrolysis, producing hydrogen chloride gas. Okay. Now in IUPAC system, acid chlorides are named by replacing the E ending of the parent alkane by suffix OYL chloride. Okay. Now the electron withdrawing inductive effect of acyl chloride is not stabilized by electron pair donation. The electron withdrawing inductive effect of chlorine makes it more electrophilic and more reactive towards nucleophilic acyl substitution. This is a pi bond, electrons are shifted and therefore oxygen getting negative charge, and as this carbon is a carbocation, it is a two, that is electrons are again shifted on the carbon. Okay, and thus the reactive compound is obtained. Okay, methods of formation. The first method, from acetic acid by the action of phosphorus trichloride or pentachloride and thionyl chloride. The first reaction of acetic acid with phosphorus pentachloride giving acetyl chloride, and with phosphorus trichloride again gives acetyl chloride. Okay, and with thionyl chloride, acetic acid gives acetyl chloride. Then chemical properties. It is powerful acetylating agent, a reagent that introduces acetyl group, especially with compounds containing hydroxyl or amino groups. The first reaction with water, okay, with water it gives acetic acid, okay, with water acetic acid is formed. With ethanol it gives ethyl acetate. With phenol it gives phenyl acetate. With ammonia, when ammonia is passed, it gives acid amide. Okay, ammonia is passed, this is acetyl chloride. Ammonia is passed, acid amide is obtained. Uses: first, it is of course acetylating agent. It is an important organic reagent. It is used in the preparation of acetic anhydride and in the detection and estimation of alcohol and amino groups. Another derivative is acid anhydride derivative. The formula is RCOOCOR. Okay, it is colorless, pungent smelling liquid insoluble in water. It is not as reactive as acetyl chloride and it does not fume in moist air. Like acetyl chloride, it reacts with alcohol, phenol, amine, though less reactive. Normally, acetylation using acetic anhydride is carried out in the presence of sodium acetate or concentrated sulfuric acid as a catalyst. Methods of nomenclature. Okay. Now, nomenclature, there are two methods, common names and IUPAC name. The first, in naming the word anhydride is added after the IUPAC name of the corresponding acid. Okay. Here common name is acetic anhydride. But what is the IUPAC name? Ethane, and therefore ethanoic anhydride. Succinic anhydride, carbons are 4, therefore butanedic anhydride. And this is phthalic anhydride. IUPAC name is orthobenzenedic anhydride. Methods of formation. The first method is dehydration of acetic acid. When the vapors of acetic acid is passed over phosphorus pentoxide, that is a dehydrating agent, water molecule is removed, okay, and acetic anhydride is formed. This is acetic acid. Heating gives acetic anhydride by losing water molecule. Chemical reactions with water, acid anhydrides are hydrolyzed with water to give acid. This is the reverse of above reaction. Acid anhydride on action of water converted into acetic acid. Therefore, the reagent must be used in the dry condition. Okay. The second reaction with alcohol. When they react with ethyl alcohol produces ester. Okay. Acetic anhydride reaction with ethanol giving ethyl acetate ester. Okay. With ammonia, ammonia rapidly reacts to give acid amide. Okay, this is ammonia reaction giving acid amide. The ammonolysis, the reaction is known as ammonolysis. Okay, the attack is shown here. Now, uses of acetic anhydride. Of course, as acetylating agent for the manufacture of cellulose acetate, and in the manufacture of tablet aspirin and some drugs. Students, with this we have completed this topic. Thank you.